Good afternoon. Today I wanted to give you a brief synoptic overview of the severe weather risk heading into parts of southern Quebec, Ontario, and then leaking into the States, with the main concerning areas being Quebec City, the Trois-Rivières, Sherbrooke, and even Montreal if it's out in the outer vicinity. Some of cottage country should get in the risk later, at least if some of the convection allowing models are to be believed, but that one part remains to be seen. The main risk zone is northwest flow, or the main risk parameters are because of northwest flow and a cold front, a weaker cold front that comes through the area that kind of acts like a pseudo dry line. It's not like in the winter times where that cold front's like a bulldozer that just clears everything out and convection fires along the line the whole way. This one's kind of hinting at more discrete thunderstorm signatures, perhaps even supercells within this vicinity because of more piecemeal forcing for ascent. So that will be supercells with a tornado risk, mostly with damaging wind and torrential rain will be your main hazards, but the tornadoes are a risk, and we'll discuss that shortly. So I'll show you the United States version too, and this is the SPC parameter outlook, which has an enhanced risk and a Sig 1 10% risk for parts of Maine that continues as thunderstorms are expected to fire Canada side first and then head into the vicinity in the States later on today. And it's pretty clear why when you can see exactly where the ridging is that's forcing this flow over the ridge when you have your temperature contrast between the subsidence, sinking air, ridge, warm temperatures, and above the ridge is, of course, a lot cooler. You get your temperature gradient, you get flow established that gets squeezed between and it heads down range. And you can see it so clearly on the map. You can see exactly where the ridge is. You can see the ridge centers pretty much in the Iowa vicinity. You can see it's kind of elongated too, because even my area here in the Great Lakes is still not a cloud in the sky or barely any at all. You can see this haze here. That's wildfire smoke that's being carried down from Western Ontario here. You can kind of see them here. It's being caught in the flow and dragged down range. But you can see basically that's what the premise is that your ridge is here, your flow flies above the ridge. That's that ring of fire flow. So you can expect thunderstorms to fire today in central Alberta, kind of in the Edmonton vicinity. It's expected to be a severe weather risk for parts of the southern plains, especially across Saskatchewan into tomorrow as well. And then today, which we'll discuss primarily, is this vicinity, eastern Ontario and mostly southern Quebec. And as long as this ridge is around, these temperatures are going to be soaring. So you've already breached 100 in parts of the western Dakotas, and it's expected to continue across this area for a while. But it will shift a little bit going forward. So like you can see on the ensembles, you're expected to see going forward that into next week, into Monday here. Northwest flow is more established across the Great Lakes in the Northeast, so it'll be cooler, more comfortable temperatures and dew points than we currently have. But ridging is still established over the west coast, or it's sort of like the Rockies four corners into the west, and you'll see the temperatures correspond as a result. So like this heat will continue going forward at least into early next week in this vicinity and across parts of the western United States, and maybe even getting into the southern plains of Canada, and temperatures get a lot cooler and more comfortable across the lakes. For the severe risk for Quebec, the main culprit is because of this flow. You've got a really strong jet stream aloft. Even if this isn't perfectly accurate, the main parameters are through the roof. They're over 100 knots across northern Ontario. You've got a jet streak embedded. You've got upper level divergence in the zone downrange of the jet streak, which is along with that cold front, which poses your risk. So you've got plenty of upper level support. Your mid level support is through the roof. You've got almost, well, at least low 60s, high 50s support across almost the entire area, higher even when you get involved in this particular interest area we're going to be discussing. Southerly flow is the same, pretty intense for this time of year, I would say, especially across the Great Lakes, and especially in northwest flow where you've got even 30 plus knot barbs across the greater Toronto area and my area, and across the area of interest, it's supposed to be in the mid 30s, and you can see your kind of switch or your backing in your flow downrange in this vicinity as well, because you're looking it's not as prominent around. Let me see 3 hours ahead, see if it makes what's about the same. But you can see the shift, and I'll pull up a sounding to show you what I mean here. You can see your temperatures are kind of established from the northwest flow, but then when they come closer to the surface, they back a little bit. They come back closer to south. And that influences that low level kink in the hodograph, which increases your storm relative velocity and increases your tornado risk on discrete supercells. But you can see, because there's so much humidity in the air, like look, when I like this isn't even exact, even if this is low or high. The main point I'm showing you this is to give you an idea of, it's just very hot, very muggy, and it's providing a ton of fuel for the atmosphere. This area here earlier, the area of interest we're looking at, west of it was, well, I don't know where it went. It was showing 3,000 Cape. This area here is a bit overrun by thunderstorms earlier. You can see they were still running through the vicinity, so you've still got some cloud cover. You've still got some convection around in the area that's preventing recovery going quickly. But because it's the summertime, it doesn't take very long to recover, as opposed to early spring, where thunderstorms rolling through at 3, 4 in the afternoon, I think, would just cook the risk. But not necessarily in the summer, because you've still got several more hours of daytime heating, several more hours of diurnal heating available. And there you go. So like this particular area is building. You still have some capping in this area. Your cold front somewhere in this vicinity here, because you can see the difference between basically zero Cape and increasing Cape as you go further south. The cottage country influence in this zone is seeing 2,500 to 4,000 Cape. So as the cold front comes through both vicinities, there will be a risk for both particular zones. More so in this particular area, though, as you see these thunderstorms clear out. And like the temperatures are like, you basically, I'll pull up a sounding. I'll pull up this sounding. You've got plenty of dew points, high temperatures, low spread between them. You've got low LCL heights, which means your cloud heights are low in the atmosphere. You've got backing in your low levels, plenty of backing in the low level hodograph. You've got a mostly straight otherwise, besides this low level backing, and this is a pretty typical northeast looking hodograph. For people that haven't seen this much, like if you're used to plains chasing where your backing is more from the southeast, and then it veers as it continues up. This one's a more traditional northeast sounding, which might throw you off a bit, but it's still the same. You're just tilting your hodograph a bit. In this particular instance, you still have plenty of low levels. Your storm relative velocity isn't through the roof, though it's still a damaging risk. It's still a threat for tornadoes. The reason being is there's no real surface low in the area to focus it back as if it was going to the southeast. It's more this cold front that comes through, which kicks the storms off. So that's why your helicity isn't through the roof. But it's still reasonably high, and the hodograph suggests it's going to remain this way in the high 150 to 200 range going forward, which is plenty, especially for rotating storms that potentially pose the tornado risk going forward. So we'll see how it evolves. The thunderstorms continuing and having severe risk earlier in the day kind of might have delayed things a little bit going forward, but it's still within the vicinity. And again, you can even see the flow established when you're looking at the radar here. You can see exactly where storms will be tracking directly into this area here. Montreal might be a little bit north of it, but not quite out of the range of it, especially if there's congealment and it comes further south as like more of a Boeing segment. That's going to be kind of, we'll see how the forcing goes when the cold front continues south. But in general, that would be your risk level for this area, is much like it was already pointed out earlier. Damaging winds, severe risk, potential tornadoes on discrete cells that can tap into potentially stronger winds later in the day, especially in the low levels, if they continue. And that would be my brief overview. I promised I wouldn't make it long. I usually make the blogs longer, but in this case, this is one of my first forays into doing a live forecast. So if it's full of botches, don't worry. Hopefully we work them out. Thanks for tuning in. Thanks for watching.